AI changes the secure development lifecycle. Code, data, models, prompts, APIs, and agents all become design concerns. In this topic, we'll look at how to embed security from requirements through operations, so risk is managed continuously instead of discovered too late. We've established who can access what: identities, permissions, agents, and secrets. Now we'll move into how AI applications are designed, built, reviewed, and operated securely, including prompts, models, embeddings, tool calls, APIs, and data protection controls. AI does not replace the Secure SDLC. It expands what the SDLC must protect. Traditional controls still matter for code, infrastructure, dependencies, and data. AI systems add probabilistic behavior, where prompts, context, retrieval results, model APIs, and tool calls can all influence outcomes. So requirements, design reviews, testing, and operations must also check for misuse, hallucination, data leakage, unsafe outputs, and unauthorized agent actions. Security now has to cover both software behavior and model behavior. Security in AI cannot be added at the end. It needs to travel with the system from the first requirement through daily operation. Start by defining acceptable use, data limits, regulatory obligations, and safety constraints. Then validate the design, trust boundaries, model access, prompt flows, identity, and data movement. During build and test, combine secure coding with abuse and prompt testing. After deployment, continue monitoring behavior, drift, incidents, and runtime guardrails. Strong AI security begins by turning broad concerns into testable requirements. Define what the system is allowed to do and what misuse it must block. Classify the AI assets involved: prompts, training data, models, tools, APIs, and generated content. Then map privacy, integrity, availability, safety, and audit needs into controls. The takeaway is clear boundaries: what data can enter, what outputs are acceptable, and what actions an agent may take. A secure AI application should not be one large trusted blob. Treat each capability as its own zone: user access, orchestration, retrieval, model calls, tools, and storage. Place policy checks between those zones so requests are authenticated, authorized, validated, and logged. Keep models and vector databases off the public internet, and give tools only the permissions they need. Just as important, capture structured telemetry and audit trails, because both prevention and investigation depend on visibility. Threat modeling asks, what could go wrong and who owns the fix? Start by naming the AI assets: prompts, models, data, credentials, APIs, and outputs. Next, trace trust boundaries across users, applications, model providers, tools, plugins, and data stores. Then test realistic attack paths, such as malicious prompts, poisoned documents, compromised services, or agents with too much authority. The goal is not paperwork. It is concrete mitigations assigned before implementation begins. Think beyond the happy path. A misuse case is a plausible wrong use, such as an employee asking an AI agent for restricted customer data. An abuse case assumes intent, like prompt injection hidden in a document. An attack path connects weaknesses: overbroad identity, weak validation, trusted model output, and automated actions. For each path, define controls that prevent it, detect attempts, and support rapid response. When an AI system connects to APIs, retrieval, or tools, raw text must never drive privileged behavior on its own. Prompts, documents, model responses, and tool outputs are all untrusted until checked. Safer code validates parameters, enforces allow lists, applies policy checks, and only then executes actions. Keep secrets and business rules out of prompts. Also use conservative timeouts, retries, rate limits, and error handling, so failures do not become security gaps. Every piece of text sent to a model is part of the security boundary. System and developer instructions need clear priority over user input, and retrieved context should be labeled as untrusted, so it cannot issue new commands. Use templates with controlled variables instead of free-form concatenation. Send only the context required for the task, especially when data is confidential or regulated. Tool responses need the same filtering before they influence output. With agents, security must control both decisions and actions. Limit which tools the agent can use, which parameters are allowed, and how far execution can go. Before any high-impact step, such as changing data, moving money, or altering privileges, enforce an authorization gate. For sensitive cases, require human approval or step-up authentication. Finally, capture tool calls, inputs, outputs, and decision checkpoints so behavior is auditable and unsafe actions can be stopped. Treat every model response as untrusted until your application checks it. Before content reaches a user, database, or tool, validate the format, filter unsafe code, malicious links, and policy-violating material, and enforce the same authorization rules you would for any other system. Errors should be helpful but not revealing. No prompts, stack traces, tokens, or configuration details. Logs need the opposite balance. Enough context for audits and investigations, with secrets and regulated data redacted. Secure AI delivery works best as a series of gates, not one final approval step. During review, prompts, retrieval logic, permissions, and data flows are checked before they become code paths. Before release, teams validate access controls, configuration, environment separation, and rollback plans. After deployment, the gate becomes continuous monitoring for abuse, unusual tool calls, leakage signals, and model drift. The goal is to catch AI-specific risk before it reaches users and keep catching it afterwards. A secure design review is where architectural risk gets caught before code hardens it. For AI systems, treat prompts, models, tools, APIs, identities, data stores, and logs as one connected system. Ask where trust boundaries sit, who or what can act, and how permissions are constrained. Trace data from input to retrieval, model output, and storage. Then verify encryption, secrets, policy checks, audit trails, incident hooks, and clear operational ownership. Anything unclear is not a pass. It needs review. The key lesson is that AI security extends the SDLC. It does not replace it. Treat prompts, models, data, agents, and outputs as assets to protect. Build AI threats into modeling. Enforce secure design and coding controls, and use deployment gates. Next, we'll go deeper into testing and supply chain defenses.